Okay, thank you. While I presented this information at a few events based in the US, I have never actually presented this information in Ontario. So please excuse the delay, but I haven't had the opportunity really until more recently. So yeah. So eastern small-footed myotis, as we know, was listed as endangered in Ontario in 2014 due to white nose syndrome. The recovery strategy was worked on between 2015, 2016, and finalized in 2017. But when we're sort of working on that, things that we need to talk about in the recovery strategy, how do we recover a species at risk? We need to understand what its distribution is, population sizes, and habitat. Where is its habitat? A big part of the recovery strategy is developing an area recommended for habitat regulation, and you can't really develop that unless you know what its habitat is. So for this species, we really knew very little about where it was roosting before preparing it, the recovery strategy. Some recent information out of the US had started to indicate that the species was probably roosting in rocky habitats, open, sunny, rocky habitats. But we didn't have any information like that in Ontario. So that was a really big, important step to try to doing some work to find out where the habitat for the species is in the province. So I don't need to probably say too much about the Niagara Escarpment in Ontario, but as we know, it's a very prominent feature that contains cliff and talus. The more prominent cliff and talus locations are sort of the Bruce Peninsula and then down around sort of the Halton region, I would say. And most of our talus is not open, right? Most of the talus is pretty treed, but there's some small areas of open talus as well. So in 2016, we carried out a primarily acoustic study. We wanted to know, is small-footed myotis using cliff and talus habitats on the Niagara Escarpment in the summer specifically? So along with the other species, we do have records of the species hibernating, at various hibernacula throughout the province, including hibernacula on the Niagara Escarpment, but really didn't have any summer records, especially maternity records. And if so, if they are in these areas, are there sort of seasonal patterns in that activity that we might be able to detect from acoustic surveys? So acoustics were the answer for that. But then the other question, because as those of us who do acoustic monitoring know, differentiating various Myotis species acoustically is very challenging. So in order to just sort of verify, is small-footed Myotis actually at these sites, we did some capture surveys as well, just to confirm that. So we had 3 study sites. The first site was a natural cliff and talus site on the Niagara Escarpment, on the Bruce Peninsula specifically. The second site was another natural cliff and talus site in Halton region. And the third site was actually an abandoned quarry with, so it has these cliff faces from excavations and sort of this makeshift talus slope made up of large boulders. So for our capture surveys, as you can see, our acoustic detectors were on poles in these open talus habitats, trying to minimize clutter as we can, as much as we can, in the little pockets of openings. And the netting, we did net directly on the talus slopes in 2016. We mainly put our nets in between patches of vegetation. There wasn't really any overhanging vegetation that we could take advantage of. Certainly there's no puddles on a talus slope. So we netted directly on the talus with the net as close to the ground as we could get it, and between the patches of vegetation. The reason why we wanted to net directly on the talus too, part of that reason was because Dr. Paul Moosman in the US, when he had been netting on talus slopes in habitats that contain maternity colonies, he would net on the talus slopes and capture eastern small-footed Myotis that way, and found that to be effective. So we wanted to do the same thing. And our nets were essentially parallel to the cliff or V-shaped. We tried a couple of perpendicular to the cliff nets and just never really caught anything, so we just stopped doing that. So for our first site, we did 4 survey nights and we caught 3 bats, and all 3 of them were eastern small-footed Myotis. So that confirmed a new site for them, which was great. Acoustically, eastern small-footed Myotis represented only 2% of auto-classified calls, and small-footed Myotis was most abundantly classified in May at this site. At our second site, again, we did 4 capture survey nights. This site, we caught a lot more bats. We caught 13 bats, and 7 of them were eastern small-footed Myotis, so over half. We also captured little brown Myotis and big brown bat. So this was another new site confirmed for the species, and part of the reason why we caught so many bats was because there was actually swarming activity sort of happening behind the talus, between this talus pile and the cliff. So that was a new swarming site that we identified, so that was really great. In our acoustic data for this site, similarly, eastern small-footed Myotis was 4% of all auto-classified calls. But in this case, they were most abundantly recorded in July and August, which sort of matches up with that swarming activity. And you can see that big brown bats really dominated the acoustics at this site compared to the Bruce Peninsula site, which was dominated by species at risk bat calls. And at our third site, we did 3 nights of capture here. We captured 2 bats. Both of them were little brown Myotis. So no eastern small-footed Myotis were captured here at the abandoned quarry. One of the little brown bats was actually captured really low in our net and had a lot of dried mud on it, like dried dirt. So we suspect it was probably roosting in the rocks there, at least for a little bit. So that was really interesting. But at this site, Dr. Mooseman had actually come out in the spring to do a little bit of a training session with a few folks on doing visual surveys, since that's the method that he mostly employs to monitor populations of the species in the US. And he had us sort of spread out and start trying to look in crevices. And it was really interesting because we were all trying to look in crevices, and then once Dr. Mooseman got started, he zeroed in on a crevice, went there, and there was an eastern small-footed Myotis in the crevice. So he clearly knows what he's doing, and he has that visual search pattern really nailed down. But our netting wasn't really effective here compared to the other sites, so that was interesting. Also interesting, in the acoustics, small-footed comprised 21% of auto-classified calls. So a much larger proportion of the calls than when we were netting at the natural cliff and talus sites. And they were most abundantly classified sort of more from May to about mid-August, which was interesting because there is a hibernaculum also very close to this area. So just, I don't know, interesting, I guess. Interesting to see those seasonal differences. So sort of recapping that, was acoustic monitoring successful, for detecting the presence of eastern small-footed Myotis? Yes, but just because we had more calls didn't equate to more captures for us. And overall, we were thinking, wouldn't it be awesome if we caught an eastern small-footed Myotis? And it turns out that it wasn't really that hard. Which is really great, but we just needed to net in the habitats where they're theoretically living, in these sort of challenging, difficult to get to places. And yeah, they were not easy to capture in the old quarry, obviously, but fortunately, Dr. Mooseman was there, so we got that confirmed. So in 2017, we followed up on our acoustic work on eastern small-footed Myotis by asking the question, where is this maternity and summer roosting habitat? And really the only way at this time that we can know for sure where roosting habitat is by doing a radiotelemetry study. But we also wanted to know where visual search is helpful, because they are helpful in the populations that Dr. Mooseman studies in the Appalachians. Are they helpful for us here? Are they helpful to help find colonies? Could we use data from visual searches to sort of supplement the information we get from doing radiotelemetry? And are there other species roosting in the same area? Could we come across big brown bats or little brown bats roosting in the same places too? That would be interesting to know. And I'm just going to cut straight to our visual search results. So we conducted visual searches at our 4 study sites that we had in 2017, plus a bunch of roadside rock cuts. So we searched for 17 polygons, 37.5 hours, and a bunch of other unstandardized searches, and we never found any bats. So not super useful. Noting that when we're doing visual searches, we can only sort of do them in the places that we can reach. So on the talus and maybe the bases of cliffs, but what about all the cliff further up, right? We couldn't really reach any of that. So we repeated our capture surveys at the 2 sites where we caught eastern small-footed Myotis in 2016. The natural roost and talus sites, and we added 2 new natural roost and talus sites that looked promising, some more open, sunnier, rocky areas. This was one of our sites though, and so you can see here, like the cliff is pretty far away from where the path is. And I wasn't super excited about the thought of walking 300 meters in the dark over like no paths, over treed talus with boulders everywhere, lugging a bunch of equipment. So instead we netted over the puddle on the trail, which is, in general for any species, that's a great place to net. So we netted around 2 to 3 nights at each of our sites between May and August, and a little bit of extra netting with no radiotelemetry in September. In general, we didn't really catch much in the spring. We didn't really start catching anything until sort of late June. Overall, we captured 44 bats between the 4 sites, and eastern small-footed Myotis was the species that we captured the most. Fairly low species diversity though, just also again big brown bats and little brown bats. Study site 4 is the same site where we caught the most bats in 2016. So we caught quite a few there. And you can see study site 1, we didn't capture any small-footed at that site. That was a natural cliff and talus site again as well. But we did capture them at the remaining 3. In terms of composition, study site 3, which was a repeat, it wasn't. Yeah, study site 3 was a new site. 80% of the bats we caught there were eastern small-footed Myotis. So how many eastern small-footed Myotis did we capture at night? Well, it ranged from none to 2.6. So sort of on average, we got this sense and kind of bared out when we did the analysis that when we go out to try to capture eastern small-footed Myotis in talus habitats, we generally can expect about 1 bat per night. So we applied the smallest size of transmitter that we could get from Hollow Hill to eastern small-footed Myotis to try to stay within that 5% weight range that Shane mentioned. They don't make this transmitter anymore. That's because it requires really, really small batteries, and they have to buy it in bulk, but not that many people order them. And that did become a bit of a problem for our study, as we'll see. So we attached transmitters to bats at the 3 sites where we captured small-footed. That included 9 adult males, 1 lactating female in mid-July, which was exciting, and 1 juvenile male in mid-August. So where were they roosting? Some pictures of their roosting sites. They were roosting deep in crevices, high up, and out of our reach. So we didn't really confirm not any, but most of these bat roosts we couldn't visually confirm. Except for the juvenile male. In mid-August, we tracked the juvenile male to this large boulder, a crevice. You can see the large crevice in this boulder. And there's the little guy hiding out in the crevice. So mid-August, we can't really confirm that this is maternity habitat. It's a little too late, but it could be maternity habitat, as we know the juveniles will hang around maternity sites longer than adults will. And certainly that could have been a maternity site, but we can't really say for sure that it was. Dr. Moosman, when he saw the photo of this roost, said that that's the size of the boulder and the type of the crevice that he normally sees maternity, like females with juveniles in at his sites. So we can be optimistic. So in general, we were able to track 1 to 3 days per bat. And we got roosting locations from 6 of the 11 bats that we tagged. And we identified 11 roosting sites. So that's a little bit, low, low even for radio telemetry. For 5 of our 11 tag bats, we didn't get any roost sites at. And so speaking with Holla Hill about how this went, and not being able to pick up any signals whatsoever from a bunch of our bats, and them cutting out, a lot of them cut out after 1 day or 2 days. That's the battery issue. So having to buy them in bulk, they sit on the shelf. Not a lot of people buy them, so the batteries were probably quite depleted. So these things happen. In terms of our tracking results, here's one of our sites, and the pink lines represent the locations where we netted. This is my cottage. So up on the talus slope in the open, and then this male that we captured here, an adult male, roosted immediately beside our net location in the cliff. So 30 meters away on 3 different days. 30 meters away, but if you want to walk from my cottage up to where they were roosting, it's a 45-minute hike because you have to go around in order to climb up the escarpment. Yeah, especially here, there's 2 levels of escarpment, like the two different rock types. So yeah, to even get to the bottom of the cliff there, you have to walk 45 minutes around. This was the juvenile male from that site. Our net location's about 170 meters away, but here's our one roost site where we found the boulder, and some, our other telemetry points and triangulation. As you see, kind of messy looking. It takes a long time to walk all the way up to the cliff to take one point, and then, okay, well, now we've confirmed, oh, it is down there. Now we have to walk all the way around. That's a 2-hour hike. So it takes a long time just to go that small distance to try to find the roost site. Here's our one site where we netted on the puddle over the path. So again, they were roosting in the cliff, like immediately adjacent to where we netted, in this case, 300 meters away. So the male here is in blue and the female is in pink. And yeah, they're roosting in the cliffs again. This location was where we tagged the most bats. 6, I think, were tagged at this location, and we only had one day from 1 bat from this location. So yeah, you can see our net's 12 meters away. It was roosting literally right beside where we captured it. Again, it was only 1 day, maybe he was just a little traumatized. But similar to the pattern at the other sites where they're really just in the cliffs very close to where we netted. And this one's a little bit more of a mess. So these roost sites were 730 meters and 850 meters away from where we captured them. So this is the same cliff section as the lactating adult female, just further down the way. So some of them were a bit further from our capture sites, but again, we captured them. They were roosting in the cliffs in that section where we were. So in summary, for the linear cliff and talus habitats that we have along the Niagara Escarpment, the mist netting seems to be effective for capturing them, but you do have to be sneaky because small-footed are really good flyers. They fly low and slow, so they can more easily see the nets and avoid them. So we did have to be pretty sneaky with where we put our nets. We netted directly on the talus in openings between clutter and on puddles over nearby trails. And they roosted mainly in cliffs, but also in a talus boulder. And yeah, we need radio telemetry to identify this. We can't do this work without radio telemetry. And visual searches were not helpful. So we answered that question. Not in these habitats, right? They're roosting way up high. It's no wonder that we didn't really find anything when we were doing visual searches. And many thanks to the tons of people who helped with this study and the Ontario Species at Risk Stewardship Fund for funding the project. And extra special thanks to our field crew who did the radio telemetry, Kelsey Huffman and Lindsay Russidi. Did a lot of hiking, a lot. So thanks. Any questions?
Okay, we have 5 minutes for questions, so there's lots of time. Any hands? There's one.
Thanks, Christy. That was great. Really interesting. I remember watching the videos or like the presentation that Dr. Roosting made for, I think it was for MNR back in 2016 or whatever. and seeing some of the pictures of the talus and where he was searching and all the rest of it, I'm wondering, anything, it's probably impossible to answer based on the amount of data that we have, but I'm wondering if there's differences in where he was finding small-footed in the talus on the sites that he, does field work at versus the escarpment. So the talus is pretty limited, I guess, typically at the escarpment. Like there might be some big boulders, but it's not like spatially expansive typically. And then I don't know if at his sites there was like a big, basically rock cliff in front of the talus. And that might explain why the bats here, are finding in kind of safer places than being on talus on the ground. So just maybe any thoughts on use of talus in other places versus where you were finding them, which is in the actual cliff of the escarpment.
Right, so thoughts on differences between where we're finding bats roosting on the Niagara Escarpment, cliff, which is mostly cliff environment, versus Dr. Mooseman's work in the Appalachians, which was sort of more talus, but occasionally cliff. So yeah, I think that's sort of the difference from what I've seen from the photos too. Their talus slopes are a lot larger, they're really long. I think they're sort of less associated with cliff and more just associated with mountain. I don't know exactly, but I know that he has described finding a lot of maternity roosts, like where one boulder is on top of another boulder, and like there's like a little crevice sort of like that. So it could be that, those talus slopes are composed of larger boulders that are making more of those types of crevices, whereas our talus slopes, where they are open, and not totally covered in poison ivy, where they are open, most of those rocks are smaller, right? Like, not all of the sites have the really large boulders, which are that dolomite capstone rock, right? The one site, I mentioned the 2 layers. The lower layer is like the small rocks, and the upper layer is the dolomite capstone rock that makes the big boulders. So I think we just have less of that, but we do have lots of open cliff. And again, I just want to mention too, these sites that we selected were all like south-facing open sunny, or they range from southeast to southwest facing, just to make sure they were getting enough solar. We didn't bother trying at any sites that were like north-facing, so they would have been shaded basically all day.
Okay.
Just a question about the acoustic side of the study. So I noticed you'd mentioned the auto classification. I was just wondering, was there a component of manual verification or, say, a screening out of calls based on things like being out of search phase or other things that might kind of mess with the data? I was just wondering what the process was, or whether that was just kind of outside of the scope of actions taken for this.
Yeah, so for that analysis, we looked at auto classification results just because it allows for a bit more standardization, and we had a lot of data from 3 seasons. It would be very time consuming, especially some of those sites like 64% of the calls are SAR. That's a lot of calls to have to look at, and a lot of them are just going to end up being like Myotis or high frequency. So yeah, just looked at the auto classification for the standardization aspect of it. I can't remember if we actually did any manual vetting or not. Yeah, we looked at a few of them, but yeah.
Okay. We have 1 minute.
Just on the topic of the audio data, I was just kind of curious what kind of range you think you were able to get from your equipment, especially with like different source levels and different bat species. What do you think the area you were able to monitor with per site?
With the radio telemetry?
No, the audio.
Oh, the audio acoustics. Like the range around the microphone?
Yeah, like how far away were you able to? You think you were able to pick up these bats? Do you have any idea?
Yeah, I think it would have been fairly standard for all of the mics that we use in acoustics nowadays. So these were Wildlife Acoustics SM4s that we were using with U1 microphones. So there's a large debate about what the distance is, but depending on the day and the weather, 15 to 30 meters maybe.
Just remember to repeat the question for the people online.
The question was, how far away from the microphones do we think that we were able to pick up with acoustics?
Okay. All right, I think we're done. We're out of time for that. Thank you very much, Christy.